Hello and welcome. My name is Stacy Bersani, Program Manager for IEEE-HKN. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. We thank you all for joining us, and we also would like to thank our sponsor, DigiKey Electronics. Before we begin, please note a few housekeeping items. At the bottom of your screen are engagement tools you can use. All tools are resizable and movable, so feel free to move them around to make the most out of your space. Note that we recommend using a wired internet connection to access today's presentation and closing any programs or browser sessions running in the background that could cause issues. There is no dial-in number for this event. Please make sure your computer speakers or headset are turned on and the volume is up so that you can hear our presenters. You can find additional answers to some common technical issues in the orange question mark Help tool at the bottom of your screen. If you have any questions for today's presenter, you can submit them through the Q&A widget on your screen, or click the purple Q&A icon at the bottom of the screen. We will answer as many questions as time allows. If you click the on-demand link for today's event, you'll be emailed to, if you click the green resources icon at the bottom of your screen, you'll find more information about today's event and future events, including our job fair to be held on November 5th from 11 a.m. to 2 p.m. Finally, the on-demand link for today's event will be emailed to all registrants after the HKN experience concludes. Our virtual event today is New Jobs for New Technologies. During this session, Tom Coughlin will discuss how the proliferation of fast networks and the development of better online tools will enable new ways to work and a more global workforce. In addition, he will address how jobs themselves will be changing. If you'd like to post on Facebook about this event, please use the hashtags #HKN Experience and HKNx2020. At this time, I'd like to hand it over to Nancy Ostin, Director of IEEE-HKN.
Thank you, Stacy, and welcome to everyone. It's really great to have you here on day 2 of the HKN experience. We had a great day yesterday, some really good sessions today, and I'm really thrilled that we've got Tom Coughlin with us. So thanks so much, Tom. Tom is the president of Coughlin Associates, but he's also a past president of IEEE USA. He's involved in so many things in IEEE. Many of you are IEEE members, you know Tom, new initiatives and future directions and lots of really cool stuff. And Tom is a beloved HKN member, so I really appreciate that, Tom. Thanks so much for being with us today, and so I'm going to hand this over to you, and thank you for the great information you're going to give the audience.
Well, thank you very much, Nancy, and it's a pleasure to be able to join you folks today. As Nancy said, I'm going to talk about new jobs for new technologies. And work is going to change, and it has been changing for some time. When I first got into the industry, there were still people who had worked for one company during their whole lifetime. That's really uncommon nowadays. You can expect to have multiple jobs during your career. Some people may work longer, some people shorter, but you're going to move around almost guaranteed. And except for the fundamentals in your education, much of what you learn will become obsolete. The things that relate to protocols, things that people are doing right now, those will go away, or they'll be buried in everything else. So what you may do, in fact, may change a lot over time. You may be an engineer, maybe you become an engineering manager, perhaps a VP, a CTO, perhaps you start your own company. And what you work on will change a lot during your career. So, given all these changes and things that are going on, how can we optimize our working experience? So, one thing you want to do is, if you're going to do something and you're going to spend your life and your time doing it, make sure it's exciting and fun, and that teaches you lessons that'll help you develop your career and hopefully also help you develop yourself. And that leads into another important topic, which is that in addition to all the hard science and technology that you've learned, you need to learn how to work with people. So developing what's called soft skills is going to be really important. For instance, so you can communicate effectively, It's easier to get people to follow you and work with you if they understand what you're after, or if they can relate to the things that you're doing. So those soft skills are important. Another thing is leave yourself open to creating relationships and networks. Friendships that you learn in your career, people you work on, could be invaluable to the future. And if you can find someone who's got experience, who's willing to sort of take you under their wing, help you out, give you suggestions, be a mentor in that regard, that can really help you in terms of maybe finding and even then achieving your goals. And another very important thing is, as you go through life, don't grab all of the joy, all of the pleasure that you can out of it. And so creating a sustainable work-life balance is really important. In fact, having that can help keep you going even when other things seem bad. In other words, there's other people depend upon you. There's things that you've done that are good, that are represented in the folks around you, can motivate you to continue doing stuff that you consider important, even when things seem like they're against you. So we all need support at home. And I also personally believe, and it's certainly been in my careers, being part of a professional organization like the IEEE has been a real benefit to me. And I believe that it can be your lifetime professional home as well. It gives you a lot of opportunities, for instance, to learn new skills, which IEEE has a lot of different things that they can teach you to advance either in your current job, find out about other things going on, maybe find new opportunities, new skills, new capabilities. And many roles rely on knowing something about a number of technical areas. So even if you're an expert in something, you need to know about other things, partly because you may end up changing what you do over time. But the other thing is you may find new connections, or the thing you know about maybe have some analogous use in a whole nother field or whole nother area, which can lead to new advancements, new developments, maybe lead to wealth. Certainly would be part of having fun. And also, whether you're in management or not, you need to learn how to work through others, as well as working with your own efforts. Collaboration is the key to this. This can be working through your boss. That's part of what getting at the whole communication thing, to get him on board with what you want, that him or her on board with what you want to do, and to help them to help you to be successful, because that helps them to be successful as well. And as engineers, scientists, and technologists, we deal with, ideally technologists are dealing with reality, with the real world, with the way things work. And that provides real opportunities. Unlike a lot of fields where it's a lot more is positioning and it's like you're dividing up a pie, in the fields of technology, we create wealth. We create opportunities. We create things that maybe never existed before, and it can provide interesting and satisfying jobs. You can be working on new and emerging technologies, which is a really exciting thing to be working on. It's, by the way, also where a lot of the money is going to be. And if you become part of a new business or endeavor, you can make a real difference and stand out in your field. Maybe it's a smaller thing, or maybe it's a bigger thing. It all depends. And part of it's also luck. Did something you work on have a bigger impact than you even knew at the time you made it, for example? So let's take a look at some of the new technologies and opportunities that I think can fuel your career, and also talk a little bit about IEEE and some of the activities they're going on, which are helping to develop these technologies. So before we do that, though, let's look at some work statistics. According to the U.S. Bureau of Labor Statistics, employment in computer and information technology occupations is projected to grow 11% from 2019 to 2029, 10 years. That's much faster than the average growth for all occupations. And those occupations are projected to add about 531,200 new jobs, over 500,000 new jobs over that time period. Demand for these workers will stem from greater emphasis on cloud computing, the collection and storage of big data, and information security. And also being involved in technology areas like what many of us are involved in, means that you have an opportunity to earn more. For instance, the median annual wage for computer and information technology occupations was about $88,240 in May 2019. That was higher than the median annual wage for all these occupations of about $39,000. So a significant difference, in more than twice. So that's again from U.S. Bureau of Labor Statistics. And this is one part of one technical area of what many of us work in. Some people work in other areas as well, but I think it's interesting statistics. And again, I think it's part of because the things we work on actually generate new wealth. They generate new things potentially that didn't exist before, or make them work better so that people are more productive. So let's take a look at what kind of technologies will play the biggest role in creating tomorrow's world. This could give us ideas of where you might find the most rewarding opportunities for your career. And by the way, it's you're never too young to have a good childhood. You're never too old to have a good childhood, to have a happy childhood. And starting over again and actually can be exciting and new stuff, even if something you're working on, eventually becomes not as important. Getting into new things can be exciting. So after we do this, these potential opportunities, we can look a little more in depth at particular developments and talk about what may be involved in participating in those activities. And remember, you are responsible for keeping up with what is going on, remaining employable. It's up to you to develop all those skills that will help you. Other people can help, but they will help you because you're helping yourself, because you have, and because also you're doing things that help them and they can do things to help you. So there's a reciprocity goes on here. And again, just to mention, IEEE can be a resource as your professional home, providing you with tools to stay ahead of the curve, and also opportunities to meet folks and network with them and be part of something that can go beyond what you could accomplish just by yourself, because you're doing it with other people. Now let's take a look at some of the technology areas. This actually is borrowed. This I called a mandala. I think other people have as well. It's from the IEEE Future Directions Committee, and they're connecting applications and technologies together, and that's why there's all these lines that go from one place to another. And this was part of an effort to create a document in Future Directions, looking at a technology mapping where things are going, and they looked at application areas like autonomous vehicles, education, entertainment, the food chain, healthcare, Industry 4.0, retail, smart cities, and telecom. And they looked at various technologies that would apply in these application areas, future networking, artificial intelligence, augmented reality, virtual reality, various autonomous systems, working with big data, blockchain, brain interfaces, cybersecurity, fog computing, digital reality, something called digital twins, embedded communication, genomics, human augmentation, Internet of Things, processing, quantum computers, smart materials, very low power systems, a number of different technologies that were mapped out in this document. I thought it was kind of an interesting way to look at things and to see what some of these new technology areas that are developing could be, and how they might play a role in your career. This also I borrowed from the Future Directions Committee folks. It's looking at, this is a Gartner information from 2019 on what they saw as the top 10 strategic technology trends: autonomous things, augmented analytics, AI-driven developments of various sorts, digital twins. That's where you can create an emulation that can actually replace a physical thing in terms of modeling, testing, etc. Working at the edge computing, things of that sort. Very immersive technologies, again, VR, AR, that type of thing. Blockchains, what they called smart spaces, and then digital ethics and privacy and quantum computing. So this is the technology trends that Gartner saw in 2019 that were top 10 strategic. In 2020, they added to this with people-centric and what they called smart spaces. That gives you an idea what that is. So people-centric is hyper-automation, multi-experience, democratization, human augmentation, transparency, and traceability. And of course, there's some marketees in these terms like hyper-automation, but it kind of gives you an idea that it's an awful lot of automation, I think. And then what they called smart spaces were empowering the edge. That's network edges, distributed cloud, again, where you have resources in a lot of different areas, autonomous things, practical blockchain applications, and security with artificial intelligence. So that was their change in those top things going into 2020. So let's start looking at some of these various areas and talk about how this can impact you and how this might fit into work. And artificial intelligence is a real important part of this, because almost every field is talking about using AI of different sorts. And if it's AI, it's a program running. So programming is an important part of your career. You should consider that. Either doing it yourself or knowing how it works, being able to implement it, if nothing else. Equally important is creating realistic and unbiased training sets, because artificial intelligence and machine learning in particular learns from these data sets. So how do you make a data set that's realistic, that really represents the full population of people or things that you're trying to make decisions about? And if you don't do that, your AI may not do what you want to do it. So you need to create these unbiased training, realistic and unbiased training sets, so AI does what you expect it to do. And also important, of course, software is what's making the AI work, but it only works on hardware. So hardware that enables AI is another important development that can work with the software in order to create artificial intelligence capabilities, which again will be having influence, impact, and use in every field. There's also new ways to communicate, and our current pandemic situation, the fact we're even communicating here today, is a sign of just how important communication is. In the future, not very far future, and there's even capabilities available now, AR, VR, and 360-degree video, where you capture the video all around, and you basically can look at every aspect of an environment, combined with lower power display and processing technology, again, the hardware to make this possible, could increase the use of these technologies and make them a part of the way in which we engage with other people, with the world, and with information. So in addition to practical uses, these technologies can have great use for entertainment. In fact, right now, gaming is probably the biggest application for virtual reality applications at the present time. Entertainment, the future of entertainment. Some of the same tools like 360-degree video capturing that we talked about before, new types of video content, something called volumetric video, where you sample all of the light energy and the light vectors going on in a scene in order to be able to create sort of one of the things you do is you focus anywhere within the field of view with this captured content. So you can display things in new ways, and display devices that could show this kind of content could give us the ability to make more immersive artificial environments. And something like, I'm a Star Trek fan, so a holodeck, is at least doing the virtual reality visual and audio capabilities is possible. We don't have the force fields to do the physical stuff yet, or to transmit matter one place or another, but we can see the methods by which we can go into making immersive visual content at the very least. And can we create the new ways to tell stories and engage participants? Is a new type of a movie potentially within our lifetimes going to be something where you can go into the scene effectively? It seems like you're actually there, and it engages you in an artistic way, an emotional way. We haven't quite figured that out yet, but it's opportunities there, things that could drive a career as to creating the methods or the actual practice to be able to engage people in these future type of activities. Electronics and nanotechnology is another one of these important areas. It's enabling many of the things we're talking about, IoT and other technologies. They're continuing to advance, enabling new tools and methods. And just recently I heard something from Leti, where they did an announcement. It's a French research organization, where they've done a lot of work in conducting fluids within silicon structures, and they're actually can do very fast genomic analysis. Apparently, they announced with a device, a silicon-based device. I think they were also talking about making. I've heard recently the people working on making very fast ways of detecting illnesses, maybe even COVID-19, using some of these technologies. So our technologies are enabling us to make little tools and things that could work at levels we've never done before. They're enabling us to make structures and materials that we've never had before, and they can make devices that can do things, electromechanical as well as electronic things, that could totally transform, for instance, healthcare, genomics, medical testing, etc. Again, huge opportunities in the application, developing the technology and applying that technology. Engineering design. So this gets into this idea of digital twins, which is a very interesting one, in which it sort of goes even beyond just emulation, where design of systems with electronic as well as electromechanical components have become extremely sophisticated. Where physical models, and by this is true also in the media and entertainment space, to create animation, we can make things that act a lot more like the real thing because our models have gotten so much better. And there's a concept called digital twins, which I can create an emulation or virtual thing that acts in an environment like the real thing would. It can be then used for testing and development. It can accelerate product development and application. And this is started out originally with mechanical engineers and doing CAD work, but it's got computer-aided design work, but it's gotten into so many more areas and so many ways in which we can carry out this kind of approach to understand or create something that can represent and stand for another thing, a virtual thing to stand for another thing. And also this could, of course, feed into those virtual reality systems as well and make things that act much more like the real things would, further engaging us into the image that's being created. And AI used in design optimization for engineering design is becoming quite common. Again, it's becoming almost a universal tool in being able to make stuff. So in engineering design as well. So another area of development, an area where people could make significant contributions in the future. And then there's control, error correction, and compression. We have, with the development of especially a lot of special purpose processing tools, with the slowdown of Moore's law, there actually has developed kind of a plethora, almost a Cambrian explosion of special dedicated processing devices, which are meant to offload work, originally were meant to offload work from CPUs, but now are being used to create specialized capabilities that can exist in almost anywhere, in almost everything, and can create new ways of controlling and monitoring and accessing information and making decisions. So these sophisticated control methods that are enabled by these processors, enabled by processing in general, increasing using machine learning against AI, are enabling new generation of robotics, as one example. They also allow resolution of ever smaller signals, which could help us in terms of scientific advance of various sorts. For instance, going even closer to the origin of the universe and detecting that information. But it can also allow us to communicate with each other in better ways and also improve safety, I think, as well. And compression technologies using advanced parallel processing and machine learning are now being advocated as creating the next generation of streaming applications for 8K, 8,000 by 4,000, generally what that refers to, video streaming, and provide more effective communication. So 8K or even higher video streaming. So using machine learning in order to be able to make even better decisions on what I can compress without compromising the perceived quality of the image, for example. So another area where if this is something that appeals to you, something that you're learning about, there's an awful lot of applications and things that you could do there. Smart materials. Again, this ties in that whole nanotechnology area as well, where we're getting new types of materials. It may come if we combine these application-specific processors with materials and get even tighter material computing networking connections. We might be able to create programmable materials where I can make a material act, change the way it acts, what it does, on demand. These don't exist yet, but there's been things leading to that. This could be another really interesting area to be involved in. Another one is we're moving more towards an electrical economy where instead of directly using fossil fuels, we're using electrical energy. And we're also putting electronics in areas where we don't have a connection to the power grid, and we're running on batteries. But our battery technology advances have been much slower compared to other technology. If we can create smarter battery technologies, combined, of course, with low-power electronics, we can make longer battery life, more functionality in smaller spaces, and things that would last longer. You know, we can make watches maybe that, or a phone that you didn't have to charge for a week. Or we could put, with better batteries, we could put a bunch of electronics into the frames of glasses that you wear. The display is the lens. You could do augmented reality for your display. You could find out it's tied into the network. You basically could have your hands free and be able to access information and do things. So these are really important technologies, and I think there's whole careers here that are going to be finding ways in which we can make use of these technologies to create, again, new things, new wealth, new opportunity. Autonomous devices, again, enabled by artificial intelligence. We can now make devices do their own navigation, avoid many accidents. Especially in more controlled environments like robotic vacuum cleaners or lawnmowers like the one shown here, but potentially into cars and drones. But these could provide new ways, new levels of automation, new ways of doing things from what we've done before, maybe safer roads, safer transportation in general, safer and more reliable transportation. And safety, again, is a concern for larger vehicles, particularly when they care or interact with people. And this is an area actually where there's whole ethical arguments about how these devices should make decisions or what is the right decision to make. So there's a lot of stuff to be worked on in this area as well. Security, with so many people working, interacting from home like they are now, security has become a very big issue for protection of information, to make sure that collaboration isn't being spoofed and the people you think you're working with are the ones you're working with. Encryption, cloud-based security developments are needed to secure these applications as well as Internet of Things. But security has to be part of our whole lives, especially if we move into the IoT devices. They need to be secure. They need to be made so that they're intrinsically trustworthy, that they are not spying on you for somebody else, that they're your devices. So what can we do, and where in your career could you make a contribution in providing better security that helps people? Something called Factory 4.0, which is looking at all these developments in automation, artificial intelligence, Internet of Things. I can put more sensors into my tools of production that I'm manufacturing with. In general, I can create more efficient, better managed, and productive factories. They can also provide isolation from contamination and social distancing. For instance, in semiconductor manufacturing plants also, they don't want people close because people will lead to contamination and they could impact wafer yields. So there's a number of things that these manufacturing tools and working operations, which, by the way, is another career, where you can make a big impact and help to bring some of these technologies into making better factories that can, again, generate wealth, generate the products and services that help people and help more people to survive and raise their level in society. In addition, using augmented reality and teleoperation capabilities, you could do remote work or contact experts to help you with repair and maintenance of systems. There's all manner of things that are being enabled here that are creating new types of factories and more places where factories could be and maybe at different scales than they've ever been able to be at before. Smart cities is another area that's been talked about. And basically what this is talking about is building sensors and networks that are into city infrastructure and using some wireless technology, could be 5G, could be Wi-Fi, to enable communication of these various sensors and intelligence and decision-making tools. Could use for traffic control, information for driving assistance, could actually coordinate autonomous vehicles and many, many other uses. Again, another career path to be able to help to apply these technologies to make better cities and to make them more livable as well, and maybe reduce the need to transportation. Healthcare and genomics is another one. Some of the tools talked about earlier can provide faster genomic decoding, which lead to new diagnostic and treatment tools and can revolutionize healthcare, lead people to live longer, more productive lives, maybe help them recover faster, from diseases they've had. And right now it can maybe lead to new ways to detect, track, and isolate infected people that can make the next pandemic less disruptive. These technologies also could extend our useful lives. Okay, so there's enormous opportunities there in healthcare and genomics that technology is making possible. And then, of course, education itself. We've now had many months of experience of being forced to use cloud-based learning tools, of developing more robust and capable networks that can support remote communication. Even when the pandemic is done, could this change the way in which we do education? Could we not have as many buildings on campuses and colleges, and as a consequence, lower education costs, for example? New tools and applications could allow remote instruction, could provide whole new ways in which we can learn things. Digital twins, maybe in telepresence tools, could allow remote labs. New opportunities here in creating the future of education, making it more affordable, more open to all, because there is, in my mind, I almost see this as unlimited need for people who know about how things work and can make those things do what they're supposed to do. The more people we have like that in our society, the more wealth we can create, the more we can make sure that society goes. And also with the knowledge of science and the logic of the way things actually work, people may make, perhaps, though it may be a dream, people can make better choices in their lives and their beliefs as a consequence of that. Another interesting aspect, and this is one of the areas that's been looked at in future directions, like many of these technologies have been in IEEE, which is actually interfacing between the brain and electronics. This is actually in the early days of being applied to improve the lives for disabled people, allowing them to move limbs they hadn't been able to move before, for example, but also they provide improvements in education, could enable new ways to learn, collaborate, and entertain, new treatments for diseases of various sorts. There's all manner of things this could lead to, and it's a very strong area that people get involved in and really make a difference. And that leads to something which has pros and cons to it, the general idea of human augmentation. With new electronics that interface the body, perhaps directly interact with the brain, for example, like we mentioned before, we could improve the lives of disabled people. We could also maybe get a better help this to get a better understanding of human genetics, which could help make people healthier physically and mentally. Maybe we could treat mental diseases better than we have now. But there also are dangers in doing this. Could we end up with people all wanting to be augmented to become like the same sort of people? Could it lead a race? Will we lose the differences in the individuality of humans in doing something like this? Or will we create more haves and have-nots between those who can afford to do augmentation and those that can't? These are all things that need to be worked on, all things where we can develop the technologies, but we also need to understand the implications of these technologies and try to make policies that can make them equitable, useful, and generally to uplift mankind as a whole. Quantum computing is another interesting area right now. Again, this is one of those things being driven by the end of conventional Moore's law, semiconductor scaling, looking at new ways of doing computing, and quantum computing is certainly one of them. It may be able to do work that defied older computer technologies. Right now, it doesn't seem like it's anywhere close to replacing conventional computing, but maybe it can do some things that conventional computing can't in conjunction with conventional computing. But it's another area that is going to become very, very important, I believe, based upon the advances being made and how long they can keep qubits stable within the next few years. And then finally, one of my favorites, I've always been a science fiction fan. I thought by the time I was the age I am now that I'd be a crusty old asteroid miner. But I believe that we are on the cusp of ordinary people, including engineers and technologists, having the opportunity to go into space and to do things there, maybe even to live there. Within the next 10 years, I think, will be based upon both private and public things. People are saying we could resume human exploration of our moon and Mars. You know, people are going to be living and working in space in volumes of people that never existed before. There's dangers, there's opportunities. but being in a space-oriented career could literally get you in on the ground floor. And in terms of the potential opportunities, there's more stuff in space, both energy and matter, in types of matter than there is anywhere else, than there is on the Earth. It is ultimately, I believe, where our future is going to be, is for people to be living on the Earth, but not just on the Earth, and it could maybe relieve some of the resource issues we've had just being dependent upon things on the Earth as well. So some thoughts there in terms of where we could go. So in summary, work is changing, and old models just won't work well in the future. You must be ready to become both deep and broad in your knowledge and develop your hard and soft skills during your career. And for that purpose, being part of Eta Kappa Nu or being part of the IEEE, hopefully both, people can help you to do that, and you can gain networks and friends to help you to do that. And as a result of all this, the technology, which is a human thing that people make, will help us solve many problems. They'll make life easier, help us to know and do more. They will generate wealth and opportunity and help people to advance in their lives. And this means there's a lot more opportunities to contribute, a lot more. Than the more we find, the more we will find out, the more we will find new opportunities as well. So with that, here's some references, by the way, that I referred to in the talk. And also, I think now we're going to be open for discussion and Q&A. Thank you.
That's great. Yeah, thank you, Tom. That was amazing. That's a lot to take in, a lot of stuff going on. For someone to think that everything that we need has already been invented, I think, I think again, right? There's so much going on. One of the things that really struck me, Tom, was, and I've heard a lot of talk about it, is the interdisciplinary nature now of engineering disciplines, engineering and life sciences, engineering, and so much else that touches our world. Mm-hmm. And, kind of that innovation and team science approach. Mm-hmm. So I see that a lot in the stuff that you talked about. So the engineer of the future will never, and even of today, is not really just an electrical engineer or a mechanical engineer, right?
No, you got to know. Increasingly, you have to know a number of things to be able to make the best contribution.
Yeah, I think that's right. I think.
Yeah. Mm-hmm. Yeah, no, there's people that can be specialized and be a real expert, a world expert on a particular thing. And that's, but I think there's a lot more in knowing other things and be able to connect with people. There's a lot of what you can do because you know other people that can help you to do it. So it's not only what you know, it's who you know that knows something that you don't know, but that you will need sometime. That's where those networks and the soft skills come in. There's an interesting question in here. What are your thoughts on Google's Skywater PDK open source silicon? I love people who think of creative and novel ways of doing stuff. And some of the Google people have been really good at doing those over the years. I love stuff like that. Even if it doesn't itself lead to the answer, it's exercise their brains in new ways and will have an influence on the development of technology. So, and actually that's true of there's a lot of startups that don't make it. People have great ideas. The startup doesn't make it, but the idea does. Now, unfortunately, that may mean the people that did the startup aren't making the money out of it, but they do create a difference and make things, and hopefully at some point they will make some money out of it. There's another one here too. So
there's another question about, if you were starting your career now, which one of the technologies you mentioned would you be most interested in pursuing?
So I'm a digital storage and memory guy, and I kind of stumbled into that. This whole space thing I think could be really exciting and interesting. I was going to get to that at the end. So if I had my druthers and that were possible, and again, I'm a science fiction fan. I was reading all this stuff, and I wanted to do this kind of thing. I would have thought about doing that.
So you'd want to be launched into space right now and be that maybe one of those first people to get to Mars, as we're talking about today. Yeah.
Well, when you think about it and the kind of resources there, like if moving things around in space is a lot easier than moving things on the Earth, right? If I could grab a metal, asteroid and move it close to the Earth and mine that thing, for example, and send stuff down to the Earth, you potentially could make an awful lot of money, which could fund an awful lot of good things you might want to do, you know.
You're right about that. You're right about that. We had Bob Metcalf in a conversation with us yesterday, and he gave us the 3 top reasons to be an engineer. 1, engineering's fun. 2, it really pays well. And 3, you get to solve the world's problem. You get to solve the world's problems. So I think that's the things you're talking about here, about how to solve the world's problems.
Yep.
You know, he did talk about, a little bit about how engineering and the life sciences are merging, and how some of the response to COVID, and I know you've seen a lot about that even within IEEE, there's lots going on in the papers and the information about how engineers are solving and working on solutions to pandemics. You mentioned that briefly. Is there anything else you want to say about that? I find it fascinating and so timely for us.
Yeah, I think, you know, with nanotechnology innovations and some of these things, like I was referring to the Leti guys that are, you know, able to move fluids around within the silicon with silicon sensors, you know, that they're talking about doing genomic analysis, or, you know, maybe doing rapid testing for things like COVID potentially. So, you know, the interesting thing about being a technologist, a lot of professions and a lot of people spend their lives worrying about what's going to happen. The technologists are the ones that can help actually make it happen, you know, and hopefully in a good way, which can solve our problems. You know, including things like how do we prepare for a pandemic? How can we treat it? How can we make it more manageable? And I think we can make, you know, we're the kind of people, or people like us and do the kind of things we're doing, can be the kind of people that could make those kind of things possible.
Yeah, definitely. There's so much in all the stuff that you've talked about here, so many different ideas of where these different technologies are going. And I know I'm a little familiar with future directions. How many societies are there right now in IEEE? How many technical societies? It was 32. Am I still right in my memory?
Well, I think if I remember I think I looked at this a few months ago, and if you include all the councils, they have these technical councils and stuff. It's something like 42, if I remember right. Societies and councils.
Right. I think the exciting thing is if you're interested in something, there probably is a society council or maybe a future direction that you could get involved with within IEEE to really help you hone in on any of these one technologies, and be involved with people that are working on these issues. I think that's a real exciting opportunity that maybe people don't realize is available to them within IEEE, is that you have these great societies, councils, future directions initiatives that are going on, that, you know, the BRAIN Initiative and others. Real exciting things that you don't have to wait for someone to come to you. You should go to them.
In fact, I noticed one of the questioners was asking to go back to this reference slide, and so I did. And if you look at the very bottom link there, that is the IEEE Future Directions, where you can find out about all this really cool stuff going on there. I mean, you know, really exciting things, and many of the topics that I discussed today are actually being worked on in IEEE Future Directions.
Right. We're having, tomorrow, we actually have Ellie Track, who's on the rebooting computing direction. He's coming on to talk us a little bit through what's going on in that area, which is not just quantum, as you mentioned, but rebooted computing, another really interesting, you know, area, edge computing, all those other things. Anything else you can share with us about that? Because I think that's a right precursor for Ellie's talk tomorrow.
I'm sorry. What's the question again?
About rebooting computing, because we have a session coming up tomorrow on Friday about that.
Yeah, and I touched on a few of those things. I touched on the you know, quantum computing, which is one aspect of that. But there's also a whole bunch, because I've been involved in some of those rebooting computing conferences. But there's a whole bunch of computing technologies he'll probably be talking about, which have various advantages. For instance, if you don't have to be quite as exact in your calculations, and just do an approximation, you can oftentimes get results a lot faster. So there's, if an approximation is good enough, as it is for many things, right, then you can do this lower resolution computing that can give results much quicker. That's one approach. There's things called adiabatic computing. Quantum computing is one of them. There's a whole bunch of things, neural networks, you know, for basically computing technologies that emulate the way the neurons in our nervous system and brain operate. There's a whole bunch of just fascinating things. And in a sense, what we can see for things that are really useful for us when we run into limits is when we learn new things. Right? We're kind of, if we're progress oriented, if we're not willing to take things the way they are, but believe they could be different or better, that leads us to think about what could be and what could be different. And there's a question here I've got from one person here, 3 pieces of advice you give to a student or person just starting their career about how to go about getting the right skills for the technologies that are not here yet. Okay? One, let's see. The right skills. First of all, a real good skill is being excited about technology and wanting to know as much as you can about it. And I think that leads into read widely, talk to other people and interact with them on things. I'm struggling a little bit here because everybody's path is different, and everyone's method for getting someplace, even if it's the same place, takes them down their own road. But it would be find out people that, if you've got heroes, if you've got people that you think have done good things, try to emulate what they do, the good things that they did, or the things that helped them to be successful. So that's a skill. A skill is to learn what works. And I know it's kind of dumb and but it's true. It's like, try things out. Don't settle on that you know everything, or you've got the right approach right now, because you could be wrong. I think questioning yourself is important. Trying to figure out what's new and different. Trying to think of things and analogies to other. If you do something in one area, is there an analogy to some other area that's better understood, that maybe could give you informational resources that you can move to understand this new area and make new inventions, new discoveries, for example. And interacting with other people and sharpening your skills by your interaction with other people. So I think those are some, that's more than 3, but I think there's some things there that could be useful for you is, question yourself, question truth, make sure that something is verifiable, that it's real. Interact with, look at analogies of things in areas that are different, but that could be translated into another area and maybe lead to new understandings. For example, if something is really well understood, or a mathematical approach is understood in one place, maybe it could be transported and used in another place. And then interacting with people and trying to connect with folks that are pushing the envelope. They will help you to push your own envelope and to go places that you may not have been able to before. Sorry. Yeah,
it's really good to hang out with really smart people, like you said, HKN or IEEE.
That's right.
A year ago, yeah, got to hang out with really smart people. A year ago today, we were actually together in California at UCLA, because today is the anniversary, 51 years ago, October 29th, 1969, of the Internet. We were with Len Kleinrock and a bunch of other Internet pioneers to talk about the Internet and the first messages and the things that happened. But the Internet's really interesting, right, because it was really a really disruptive technology. And it's really, they described it there as a teenager, right, really only in the, people think of it as one thing, but it really can go a lot of other places. What are your thoughts today about the Internet and where it's going? How is the technology that's really has changed things, and what's going to happen next?
Oh, well, the Internet is very interesting. It's fascinating that you've got an unreliable network that can be dependent upon for everything. Because that's what it is.
Well, that's true.
Yeah, it's got so many paths that one way or another, your stuff's going to probably go out. Or you've got enough time, if you do some caching, you can recover it, so we can build around it. So being able to do things with stuff that is manageable, that isn't perfect, which is what the Internet is, and be able to make that work and to accomplish a lot of things, to build protocols and technologies and understandings that allow us to make use of something that's not perfect like that. I think that's a key approach to technology. I think it's going to that the technology behind Ethernet, behind wired and wireless connectivity that this creates, has opened up enormous opportunities, will open up enormous opportunities in the future. Basically, when you talk about these IoT things, they might be using 5G, but they may very well be using, Wi-Fi, for their connectivity.
Right.
So,
right.
and that's going to be using TCP protocols. So I think we're going to be using more rather than less. And the main reason why people are able to work right now in the last few months is because of the internet.
Right. We wouldn't be able to. 1918 was very different than 2020 because of the internet. Right. 1918, when they had the last really global pandemic like this one, not
Yes.
possible. But today that is possible. So. You really, lots of interesting things around that about what are some of those situations and how we resolved them. Like Bob Metcalf was on with us too, as I mentioned yesterday, and Bob was talking about he said laughingly said couldn't do this session today without the Ethernet, so you're welcome.
Yeah.
And we'll talk to lunch tomorrow, probably say the same thing. But we really can work in this distributed fashion because of the work and the pioneers and what they were thinking about. Again, they had also mentioned being able to see into the future, and we talked about future new jobs for new technologies. So looking into the future is an interesting thing because I think they both mentioned you have to be able to look into the future to see where the technologies are going.
Well, but it's not just looking into the future. We're making the future. We're not recipients. We're not just the recipients of history. We're making history. We're creating the resources, creating the tools, creating the technologists and engineers do a lot of things. They can maintain stuff that exists, etc. But they also have we're learning the tools that can allow us to go places where no one has gone before, to do things that people have never done before, never done as well, or do it in new ways. We solve problems. We can. There's huge opportunities in things that we can do, and that's the whole thing that I'm trying to get across here is. There's a lot of things you can do, and there's someone here asked the question, can you share a risk you've taken in your career? And that's an important one because you're probably you will not learn if you don't take risks, if you don't fail. And I should know because I've had a lot of good opportunities to fail. I've been involved in a number of startups over the years, and many of them were not, basically just folded up and I never made any money on them. So those are examples of risks I've taken, but nonetheless, doing these things, you learn an awful lot. You get to meet people. You get to do stuff that maybe no one's ever done before, which even if it wasn't applicable for the thing you're doing right now, may be something you can use doing something else. So I think those are some, a generic answer to that. There's particular instances, but there's a generic answer. Take risks, make mistakes. Learn from your mistakes, do them with the right attitude. Make mistakes with the right attitude. That's I'm not perfect. I could be wrong. I want to learn from things, and if I learn from something, it can make me better the next time I have to make it to do something like that.
Yeah, I think you're right. I think sometimes you have to take that dive, right? You have to go for it, and again with enthusiasm. Engineers are usually really enthusiastic. They look at things and they don't even ask why. They ask, what could it be? What could this be? And solving some of those big problems like energy and life sciences and these integrated augmented manufacturing, all the other kinds of things, additive design, all these things that we have to look to the future, new ways to have materials and tools and ways to solve all our growing needs and how our society is changing.
And here's
somebody else asked,
oh, go ahead.
Yeah, about delving
Yes.
into one of these topics without having a lot of resources or knowledge, or even to do it as a hobby. So, any advice you can give here?
Sure. Again, thanks to the internet, we've got all kinds of resources you can get for free just by doing a search. You can learn things very easy. You can learn a lot of things nowadays, and what's really interesting is we have access to more information and misinformation than ever existed in the history of mankind. Of course, the important thing is being able to distinguish between the two, and we need to get better at doing that, and which is another one of those opportunities. But I think if you want to learn, if you want to find out about stuff to some level, even if it's not very deep, You could do that to some extent just through internet searches and just reading stuff that's online. And of course, IEEE has all kinds of resources that can help you to learn about stuff as well. So that's another venue.
There's a lot of IEEE publications. Some of them are free. Some of them are subscription-based. But I mean, we publish a lot of information. If you've got access to Explore Library, you've got the world at your fingertips. I know we HKN publishes a magazine called The Bridge, and we our issue just came out about renewable energy. Really fascinating issue. And we were working with one of the national labs. So we've been working and will be working in the future with a couple of our national labs, which I think are a great example of where there's innovation. If you want to go and study and work in a national lab, that's where they're really looking at, you kind of see the future. They're the Bell Labs and maybe Palo Alto Labs that were. I think they're that today.
And like Park or something labs. You're saying.
So exactly. What treasures are those? So, because energy certainly is one of those issues. We want it cleaner, faster, more reliable, more plentiful, cheaper, all those kinds of things. So, energy is one of those things that probably engineers can be looking at. How do they solve the problems of?
That's one I didn't even mention. That's one I didn't even mention. There's a lot of initiatives to go to greater use of sustainable energy, microgrids, things of that sort. But then you get into the issue that a lot of these are intermittent sources of energy, right? So when the wind isn't blowing or the sun isn't shining, how do you continue to provide reliable energy? So there's a whole question of baseband energy and how much you need, how it needs to work in order to be able to create a fully sustainable energy environment. In other words, it's not all going to be sustainable energy, but in addition, what else is it going to be, and how do you manage that? And how do you keep the power on and provide it at the best cost and the best availability?
Yeah, that's one. And Tom, before we end, I want to bring up one thing that you mentioned that I think is really critical. It's ethics.
Oh gosh, yes. Yeah. What's the right thing to do, and how do you decide?
Yes, I mean, ethics is one of the other big questions in all of these things, and everything we can do, should we do, right? And how we do it and what we do is important to consider.
With great power comes great responsibility.
You're right. So I think we have to.
Make channel Spider-Man.
Yeah, let's quote all of them, right? Let's quote all the great thinkers. Live long and prosper. How do we approach all of this with that great ethical standard? I know IEEE just updated their ethical standards. I know in HKN we talk about ethics in a big way. So I think that's one area that does overarch everything else that we're looking to do. Like you said, we've got a lot of power at our fingertips because of the background, the studies, the intellect of engineers, but it's the ethics that really have to overshadow all of that, right?
No, well, it has to guide. I think ethics needs to guide us in our decisions, in our choices.
Well, we're coming up to the very end of our hour. It went really fast. Tom, anything else you'd like to say as closing remarks to our audience?
Oh, just that I expect great things out of them, and hope they create a better future for me and my descendants to live in.
Well, that's good. That's great. Well, we'll work on that, Tom. I think we have got the right stuff. Some more movies. So thanks everyone for joining us. Thanks everyone for joining us today.